sorry, let's start back up. What makes a rhombus different than a parallelogram? What makes it more specific? Luke? Has 4 congruent sides. So again, it looks just like a parallelogram, but all 4 sides have to be the exact same length. What makes a square different from all of those shapes? Savannah?
It has 4 congruent sides and 4 right angles.
Lovely. It has 4 congruent sides and 4 right angles in it. So I always tell people a rectangle is kind of like the child of a rhombus and rectangle put together. So it's like a rhombus and rectangle got melded into one, and then there's what a square looks like. It has 4 right angles and 4 equal sides. So when it comes to the vocabulary from section 1, a rectangle would be an example of an equiangular quadrilateral. A rhombus would be an example of an equilateral quadrilateral, and a square would be an example of a regular quadrilateral. Okay? So just a little bit of vocabulary there, saying the exact same thing. A rhombus is a parallelogram with 4 equal sides, 4 congruent sides. A rectangle is a parallelogram with 4 right angles. A square is both. It has 4 right angles and 4 congruent sides. And then that picture at the bottom is kind of like a Venn diagram for where these shapes lie in reference to each other. So they all kind of lie under the major umbrella of it being a parallelogram, which just means the opposite sides are parallel. The rhombuses have the 4 equal sides, the rectangles have 4 right angles, the squares have both. But anything that was true about a parallelogram is also true for a rectangle, square, and rhombus. Ashley? She's absent. No, I did not. No, just saw Savannah McKenna. He is absent. Faith is absent? Okay. So our first couple problems here say for any rhombus QRST, decide whether the statement is always or sometimes true. Always or sometimes true. Now again, I'm going to write out, let's just review real quick our 5 properties of just parallelograms. Our 5 properties of parallelograms. What's one thing that's true of parallelograms? 1 second, let me finish writing this. One thing that's true of parallelograms. Tristan? The opposite angles are congruent. Okay, that doesn't change. Now, for rectangles and squares, it gets a little more specific because all the angles are congruent. But for a rhombus, even though a rhombus has the 4 equal sides, the opposite angles are still going to be congruent. What else is true? Okay, the opposite sides are parallel. Still true for all of these shapes. The diagonals bisect each other. That fact is not going away either. These are all types of parallelograms. Now, we're going to get a little more specific with the diagonals, but don't forget they're still going to cut each other in half. What else is true? Opposite sides are congruent. Again, in a rhombus, all the sides are congruent, but for like a rectangle, still true. Opposite sides are congruent. We're missing one thing about angles. Very good. The consecutive angles equal 180. None of these facts are going away, you guys. None of them. We're just adding to them. So in this first problem, it says, in a rhombus QRST, decide whether this statement right here is always or sometimes true. Draw a little picture. So I'm just going to draw a little rhombus here. I want to make sure it doesn't look like a square because no one told me it was a square. And a rhombus is a parallelogram where all 4 sides are equal. And then anything that's true about the parallelogram is true about the rhombus. So it says, is it always or sometimes true that angle Q is congruent to angle S? Well, is that one of my 5 properties of a parallelogram? Yeah, which one is it? Opposite angles are congruent. Opposite angles are always congruent in any kind of parallelogram. So this is always true. And so when I explain, I would just say opposite angles are always congruent. Any of the 5 properties of parallelograms still apply today. These are all just types of parallelograms. So then it says, in a rhombus, QRST, is it always or sometimes true that angle Q is congruent to angle R? This is where it gets a little bit tricky. When would Q be congruent to R? Well, it's not never true, but there's only one case of a rhombus where that would be true. What kind of rhombus has 4 equal angles? A square. Very good. So this is only sometimes true, and the only time it's true is if your rhombus is a square. A square is just a more specific kind of rhombus. It still falls under the rhombus umbrella. So this is only true if the rhombus is a square. The first one, always true because that's just a property of parallelograms in general. The second one, the angles next to each other are only going to be equal if it's a square. Because a square is a special type of rhombus. Okay. We'll get to a couple more of those types of problems in just a second. The second problem says classify the special quadrilateral and then explain your reasoning. So explain why you think it's that quadrilateral. So I want you guys to think about, if you're already on the next problem, what kind of, oh no, sorry. I just realized I'm in the middle of recording. I can't take attendance. Think about, on the next problem, what kind of shape you think it is. Do you mind taking attendance since I'm screen recording? Sorry.
Yeah, absolutely.
Thank you. Classify the special quadrilateral, explain your reasoning. So look at that shape. Your options are, is it a parallelogram, just a plain old parallelogram? Do we have enough information to say it's a rectangle? Do we have enough information to say it's a square? Or do we have enough information to say it's a rhombus? Okay, think about that question. You have 4 options. Do we only have enough information to say it's a parallelogram? Do we think it's a rectangle? Do we think it's a rhombus? Do we think it's a square? Who's got some thoughts? Which of those 4 shapes do we think it is? The longer you make us wait, the shorter work time we get. Angel? Why? Well, that's also true in a square. Okay, very good. You have to put that in there. Absolutely, very good. It is a rhombus because all 4 sides are equal, but there's no right angles. That's why it's not a square. And you will have some problems on your homework that are just like that. So you can't say something like, oh, it's a rectangle because it has right angles. Well, squares also have right angles, so why don't you think it's a square? Make sure you're putting kind of both facts in there. Very good. Let's do a couple more of these always or sometimes true problems. One for a square, one for a rectangle. Now again, squares and rectangles have all the same properties as parallelograms, plus a couple more. First problem says, for any square JKLM, I really think you're going to be struggling if you don't draw a visual. I think that's really important to draw a square and kind of draw in the facts that you know about a square. That's going to help the answering of the problem. Help you answer the problem. That was improper English. And it says for any square JKLM, and you don't have to put the vertices in a certain order as long as they're consecutive, as long as they're going in a circle. Is it always or sometimes true? Notice that never is not an option. The word no is not an option. Is it always or sometimes true that JK in a square is perpendicular to LM? Oh no, that is a typo. That is a typo. What does yours say? Same thing? What does it say? That's what it should say. LK is what it should say. That really was never true. Okay, try again, Miss Kelly. Is it always or sometimes true that JK is perpendicular to LK? Always true. Why? Exactly. Always true. The sides have to meet at a right angle. Have to pick? What am I doing? Have to meet. Yeah. Any square, all the sides are going to be perpendicular. Any of the consecutive sides will be perpendicular to each other. Same for a rectangle. Ooh, I forgot segment bars too. Man, this note sheet has all kinds of typos on it. For a rectangle EFGH, let's go ahead and draw a rectangle, mark up the sides, mark up the right angles, just so we know what we're looking at. Let's try and make sure it does not look like a square, and that it only looks like a rectangle, because we don't know if it's a square or not. EFGH. Is it always or sometimes true that EFG is congruent to GH in a rectangle? Is it always or sometimes true that those two sides in red would be equal to each other and the same length? It's not always true, right? It's not true right in this instance because it doesn't look like it. It is sometimes true, but only if it's a what? Square. A square is like the only time you have some of these sometimes. Sometimes true, only if it's a square. Because again, a square is a special type of rectangle. Only if it's a square would that be true. Questions so far? Even though the type of problem I'm giving you is maybe new, the information itself should not be new. Now, the next few theorems here are probably going to be brand new information to you. The first couple we're going to talk about are a couple of extra properties involving rhombi, is the plural form of rhombus, by the way. The first one says the diagonals of a rhombus are always going to be perpendicular. I'm going to highlight that. The diagonals are always going to be perpendicular in a rhombus. So that means that not only do they bisect each other, but they're also going to cross at a 90-degree angle, always in a rhombus. And remember, anything that's true for a rhombus has to be true for what other shape? A square. Very good. If it's true for a rhombus, it has to be true for a square. And you guys will get a chart that breaks all this down in one document. The other thing that's true about rhombuses specifically, or rhombi, is that the diagonals bisect each pair of opposite angles. Okay, so look at the markings here. That means if A is 100 degrees, then those diagonals are cutting them in half into two halves that are equal, 50 and 50, 50 and 50. Plus, they still follow the same thing as perpendicular, or the parallelograms, that they bisect each other. If angle A is 100, that would make angle B 80. So again, if you think about each half here, 40 and 40, plus they meet at a right angle in the middle. So the diagonals are perpendicular, and the diagonals bisect the opposite angles. So we're giving you a lot to think about here, and I recognize that. So first problem with this says find the measures of all the numbered angles in this rhombus. So we have, looks like 4 to find. start with angle 1. Angle 1. 1 is marking where the diagonals cross. We learned the diagonals of a rhombus are always, first theorem here, perpendicular. So if these diagonals, AC and DB, are perpendicular, how big is angle 1? 90 degrees. Very good. And it doesn't say you have to explain why, so you can just put the measure. Very good. Yeah, the rhombus, the diagonals are always going to cut at a perfect 90-degree angle. Here's where it gets a little more complicated. 2 and 3. Well, we also learned that the diagonals are bisecting the opposite angles, so that means 2 and 3 are for sure equal to each other. That's helpful information. Well, remember, in a parallelogram, the opposite angles are exactly the same. So whatever these two angles are, the opposite corners have to be the exact same measure. So if this angle is 61, this half of C, then this angle is 61, this angle is 61, and that angle is 61. Every half of the opposite corners would be exactly the same in a rhombus. Every half of the opposite corners is exactly the same. So angle 2 is 61 and angle 3 is 61. That'll always be true of a rhombus. So all we have left now is to find angle 4. There are two different ways of going about finding angle 4. One involves a triangle and knowing what the triangle measures add up to. One, you could think about what's the relationship between angles A and D in general, and then whatever you get for D, cut it in half. So there's a couple options here. Anybody have some thoughts, some ideas? Yeah. What equals 1? Okay, so we have a triangle right here. This is probably what I would do. It seems like the easiest way to go here. We have a nice little right triangle, and we know that all three angles have to add up to 180. This one's 90, this one's 61, so we can take the 90 and 61 and take it away from 180, and that's how we can find angle 4. So what is 90 plus 61? 151. Take that away from 180 because it's a triangle, and what do we get? 29. Now, did anybody perhaps do this kind of in their head a different way and still get 29? Because there's another way to do it. Nobody? Okay, then I'm not going to confuse you. There's a problem just like that.
Oh no, I cleared my
Oh.
throat. Yes.
Okay, shh, why are you talking? There's a problem just like that on the homework assignment, just so you know. All right, rectangles. Let's talk about the diagonals of a rectangle. Now, we kept stressing to you guys that the diagonals of a parallelogram are not the same because if it's slanted, one diagonal will always be longer than the other diagonal. But the second it stands straight up and down, now your diagonals are exactly the same length. So here it says the diagonals are perfectly congruent to each other. So that means all of AC is congruent to all of BD. That's not true about just a parallelogram, but it is going to be true about rectangles and squares. When the second it's standing at a straight 90-degree angle and it's perpendicular to the ground, those diagonals are going to be equal to each other. They're also still bisecting each other, so the halves are still the same. You can still see those tick marks, but now all four halves are going to be the same in a rectangle. So that means here, if this is a rectangle QRST, the two diagonals QS and RT have to be equal to each other. So this problem says pretend QS is 5x minus 31. Let RT be 2x plus 11. Find the lengths of the diagonals, and they'll be the same because it's a rectangle. So first solve for x, and then we'll plug x in to find the lengths of the actual diagonals. Okay, solve for x real quick. I'm going to do it in my head. Let's see how well I do. Once you find x, plug it back in to find the length of the diagonal. Find the x, plug it back in to find the length of each diagonal. They should be the exact same. Alright, I know most of you got to this point just fine, so I'm going to go ahead and jump ahead. You got here, now you're just trying to figure out division in your head. You guys can grab a calculator and divide it if you can't do it in your head. 42 divided by 3. Very good. Plug 14 in. Shouldn't matter which one you plug it into. They should come out to be the exact same thing. Now, there are still some of you who, like, you're trying to still set it equal in an equation. Once you plug things in, you're just evaluating it. You're just replacing your x with that number to figure out what the actual value is. So you don't need to set these equal to each other. You don't even need to plug it into both because you're supposed to get the same answer. So in either case, what are we getting as an answer here? 39, very good. That's your answer. Questions on that? Okay, last problem here. We're going to use coordinate geometry to prove what kind of shape we think this is. Now, I have in here check the diagonals because I think that's the easiest way, but in the past it's just totally confused people. So I think I might actually just cross that part out because even though I think it's the easiest, that seems to not be something that people's brains automatically think is the easiest. So let's go ahead and graph our figure here. Less. Now, it says my options in the directions are it's a rectangle, rhombus, or square. Now, I'm pretty positive I know which of those three it is, just looking at it. What do you guys think? Yeah, I'm pretty sure it's a rhombus. I'm pretty sure it's not a square, and I'm pretty sure it's not a rectangle. But we have to prove it using work. Now, if your only options are rectangle, rhombus, or square, why do you think it's not a rectangle? Let me just open that question up. Why do you think it's not a rectangle or square? Like if someone asks you, you're pretty positive why? Okay, I would agree with that. I'm pretty sure there's no 90-degree angles in here. Both a rectangle and a square have 90-degree angles in every corner. So let's go this route. If I can just prove one of those is not 90 degrees, that's enough to prove it can't be a rectangle or a square. I can't tell you, they're not all going to be this easy, but for this one, if you're just trying to prove it's a rhombus and not one of the other two, all you have to do is pick one of the angles and prove to me that it's not a 90-degree angle. Well, remember, if it was a 90-degree angle, then the slopes would be what? Someone said it. The slopes would be what? I did not hear it. Never mind. Reciprocals, opposite reciprocals. All right? If these lines were perpendicular, the slopes would be opposite reciprocals. So as long as I can prove that for two of these consecutive sides that the slopes are not opposite reciprocals, I will have proven it can't be a rectangle or a square. So I need someone to raise their hand and give me two sides of this shape that are next to each other, like touching. AB and what? I can't hear you. AD and what? AD and what? AB. Okay, thank you. AD and AB. I'm going to prove that they are not a 90-degree angle. They're not meeting at a 90-degree angle. What is the slope of D to A? Is it positive or negative, first of all? Positive slope. Good. And let's count how far up it goes and how far over it goes. 1, 2, 3, 4, 5, 6, 7, 8 over 2.
What?
What?
Huh?
What are you whatting about? 8 over 2 reduces to what? 4. Thank you. So D to A has a slope of positive 4. Positive 4 over 1. So as long as A to B is not negative 1 over 4, we should be good to go. So let's just prove that A to B is not negative 1 over 4. What kind of slope does A to B have? Positive or negative? Positive. That's enough to prove it. But let's just go ahead and write the slope out. It goes up 2 over 1, 2, 3, 4, 5, 6, 7, 8. Which reduces to 1 over 4. 1/4 and positive 4 are not opposite reciprocals. Therefore, this cannot be a rectangular square. If it was, spelling is hard. I'm also pretty sure I spelled therefore wrong again. I think there's an E right there. If they were opposite reciprocals, then there would be right angles, and you would have more reason to say it was a rectangle or a square. Now, you can use any property of these shapes to prove it's a shape or prove it's a rectangle, rhombus, or square, but you do have to show work. You cannot just tell us this is a rhombus because there's no right angles. You have to prove it. How do you know there's no right angles? How do you know that for a fact? Well, I checked the slopes, and they don't make opposite reciprocals or something to that effect. So if you're going to try and tell us, here's the thing. If you're going to tell us this is a rhombus because all 4 sides are equal, then you have to show us all 4 sides are equal. That's going to take a lot of work. So make sure that the reasoning that you use, you are backing it up with some kind of computation, some kind of work. Okay? You guys have 14 minutes to work on your 7.4 worksheet. Okay? It's kind of long.
The question, if they can prove that it's not 2 of the 3, that's enough. They don't have to prove why, they don't have to show proof of,
Not for this one.
okay.
But like if they're trying to prove that it's a square, then they have to prove why it's a square and not just a rectangle or not just a
4
rhombus.
sides
Yeah.
and 4 right angles.
Right.
Okay.
Yeah.
Just making sure that I'm on the same page.
Yeah.